Alright class, we are going to continue on with the idea of similarity, and you're going to see that it is very much consistent with what we did when we did with congruent triangles. In congruent triangles, we first said you needed all three angles, all three sides to be congruent, and then we found shortcuts for them. Well, now we're going to do the exact same thing with similarity. First we said all three angles had to be congruent and the sides had to be proportional. Well, now we're going to look at some shortcuts for similarity, and they should look very, very familiar. So let's get ahead and start looking at these first couple shortcuts that we're going to be dealing with. First one is called the side-side-side similarity theorem. We had congruence where if we had all three sides congruent to each other, then we had congruent triangles. In this case, we have three sides that are all proportional to each other. So AB over RS, that proportion is equal to BC over ST, equal to CA to TR. If you have all three of those, if you have this proportion of all three sides being the exact same proportion, then you have similar triangles. So this is again a theorem that you're going to want to have down in your composition book. Make sure it is there. Alright, so let's look at this problem down here, this practice problem. It's asking if any of these triangles are similar to this first triangle, ABC. So let's take a look, first looking at ABC versus DEF. We want to look at the side lengths and see if they are going to be proportional. Well, if it's going to be similar to each other, then you would need the shortest side of both triangles to be proportional, say, to the largest side of both triangles. And then the middle side would also have to have that same scale factor ratio. So let's take a look. If we look at AB to DE, AB over DE, the sides in red, those are the two shortest sides, would be a fraction of 8 over 6. We would want to see if that is then proportional to the longest side. That's the side in blue. And we want to stay the same, so AC from that triangle is 16, DF from triangle DEF is 12. And then our last ratio, the remaining side for both of them, the side that is marked in green, is going to be BC, which is 12, over EF, which is 9. And we want to then look and see if we simplify these, if we have the exact same proportion. Simplify it, we would have 4 over 3 for the first one. For the second one also we would have 4 over 3. And for the last fraction we would have, again, 4 divided by 3. So because of that, we can there say that it is true, triangle ABC is going to be similar, and again, similar just with that tilde, similar to triangle DEF. And that's all you need to do using side-side-side similarity as your shortcut. You need to check all three sides, use the short side as a ratio, a big side as a ratio, and then what's left over as your final ratio. So ABC and DEF are similar to each other. Let's see if GHJ is similar to ABC. Well, we want to set up the exact same proportion. We want to set up the short sides, which would be AB to HG. That is going to be 8 for AB over 8 for HG. We would then look and say, okay, now let's look at the longest sides. When we look at the largest side, AC is 16, GJ is 16. So far we're so good. Both of those would reduce to a fraction of 1 over 1. We need to then check what our last side is, our remaining side. BC is 12, and HJ is 10. And as you can see, this fraction would not reduce down to a fraction of 1 divided by 1. These first couple would go to 1 and 1, but this one is going to reduce to 6 over 5. So no, this one is not similar to triangle ABC. And you can say that because side, side, side does not allow it. We do not have three proportions that are good to each other. So that's side, side, side. And you could probably guess what the next one we're going to talk about is. It was the second congruence shortcut we did. Now we're going to do the side angle side similarity theorem. And this just says if you have two proportional sides this time and a congruent included angle, then we're going to have a similar triangle pair. So again, in this one, x and m are your congruent triangles. You would need xy over mn to equal xz over pm, and that's what we have right here. If you have each side around that angle being proportional, then with that congruent included angle, then you have your similar triangles. Again, another theorem that you should have down in your composition book at this time. So again, looking at the example down here, we see that we have an angle congruent, Angle F and angle A are both 53, so we want to think about side angle side as a similarity. FG is 6, and the shorter side of this triangle, ABC, is 9. So we take the two shorter sides, 6 and 9, from the two triangles. Now we want to take the other side on the other side of the angle. That includes that angle 53. So from FH, that leaves that 10 as the longer of those two sides, and it would leave 15 as the longer from AC. And again, we want to simplify it as best we can. We get 2 divided by 3, and we get, again, 2 divided by 3. So because of that, we have an equal proportion, 2/3 and 2/3, they reduce to the same thing, a congruent included angle. So yes, we would say triangle ABC is similar to triangle ABC is similar to triangle, make sure we get it in the right order, FGH. We have the same rules that applied before when it comes to having all the corresponding parts line up. We had FG and AB as our proportional sides, so AB and FG, that's this side right over in here and over here. And then the other ones that need to line up were HF, which is the outer two, and AC, which again is the outer two. So it's all about making sure everything lines up again, just like it did in the congruence shortcuts that we did before. That's just about it for these similarity shortcuts. Here are your quiz problems for today. Make sure that you take the quiz. Your quiz is going to read just exactly like they read on here. I'll give you a little hint for this first one. The two triangles that you would want to look at are triangles HGJ and triangle HFK. So when you're doing the sides, though, for example, side HF is actually 15 plus 5. So, for example, HF is the addition of those two. So HF equals 20. Just as a different way you want to see these pictures that are kind of embedded into each other. Along those same lines, you would have to add up HJ and JK to get your length for HK. So you want to, for both of these, say, are these triangles similar to each other? Write what the similarity statement is. Triangle whatever is similar to triangle whatever. And then you want to say what similarity shortcut you used for that problem. So go ahead, pause this video, finish it up, answer these problems, and then head over and take your quiz. And we will then see you in class tomorrow.